Hey there! Today we're diving into binary search. And trust me, this is going to be fast, simple, and fun. You'll see how this algorithm finds numbers in an array in just a few steps. Now, let's look at a successful binary search example. Suppose we're looking for number 30 in our array. First, we need to find the middle element. So we take the first index of the array, which is 0, and the last index, which is 6, add them together, and then divide by 2. That gives us 3. So the middle element is at index 3, which is 30. Now we compare our target 30 with the middle element of the array, which is also 30. Are they equal? Yes. So we found x equals 30 with just one comparison. Easy. Now, let's try x equals 10. First, we compare it with the middle element of the full array, which is 30. Is 10 equal to 30? No. Is 10 smaller than 30? Yes. So now we'll look in the first half array. From the first index 0 up to the element before the middle, which is index 2. Now we need to find the middle of this first half. We take the first index 0 and the last index of this half, 2, add them, and divide by 2. That gives us 1, so the middle element of the first half is at index 1, which is 10. Now we compare our target 10 with this middle element. Are they equal? Yes. So we found x equals 10 with two comparisons. Now, let's try x equals 7. First, we compare it with the middle element of the full array, which is 30. 7 is not equal to 30, and it's smaller. So we move to the left half. Next, we compare 7 with 10, which is the middle element of the left half of the array. Again, it's not equal and smaller. So we move to the left side again. And now only one element is left to check. That element is 7. We compare x equals 7 with it. Equal. Found it with 3 comparisons. Now let's try x equals 15. Middle of full array equals index 3 to element equals 30, 15, smaller than 30 to first half array, 0 to 2 middle, 0 plus 2 to divide by 2 to 1 to element equals 10, 15 greater than 10. 2. So we move to the right side, and now only one element is right to check. That element is 15. Compare with x equals 15. Equal. Found it in 3 comparisons. Now, let's try x equals 45. Middle of full array equals index 3 arrow element equals 30, 45, greater than 30 arrow, we move to the second half of the array, which is from index 4 to 6. Now we need to find the middle of this second half. We take the first index of this half, 4, and the last index, 6, add them together, and divide by 2. That gives us 5. So the middle element of the second half is at index 5, which is 45. Compare x equals 45 with this middle element. Equal. Found it with 2 comparisons. Now let's try x equals 40. Middle of full array equals index 3 to element equals 30, 40, greater than 30 to move to the second half of the array, index 4 to 6. Middle of this second half equals index 5 to element equals 45, 40. Smaller than 45 to only element left on the left side is 40. Compare with x equals 40. Equal. Found it in 3 comparisons. Now, let's try x equals 50. Middle of full array equals index 3 to element equals 30, 50, greater than 30 to move to the second half of the array, index 4 to 6. Middle of the second half equals index 5 to element equals 45, 50. Greater than 45 arrow only element left on the right side is 50. Compare with x equals 50. Checkmark equal. Found it in 3 comparisons. And that's a wrap on our successful binary search. You've seen how this super fast algorithm can find any number in just a few steps. Keep practicing, and soon it'll feel like second nature. Thanks for watching, and see you next time.